we're going to take what we have learned over the last 2 weeks and apply it now to evaluating the 6 trig functions. But this time, instead of being provided with degrees, we're going to be provided with radian measurements. As a reminder, going back a few weeks, we talked about these common angles. And so I taught you one shortcut is this is 30, 60, and 90. And maybe you memorized those numbers, but you didn't know what we were talking about. That's this angle down here. So 30, 60, 90, 120, 150, and so on. And then this was the 45. So 45, 90, 135, and so on. Okay? That's going to come into play. And so that's why I asked you when you came in to pick up one of these and back. We're going to start with this first problem. Now, we need to locate where 5 pi over 3 is. So I'm always starting with the bottom, and I want it to be a 4 or a 6. And if it's not a 4 over 6, I need to multiply by both the numerator and the denominator until the denominator is a 4 or 6. Is it easier to use mental math to turn this into a 4 or 6 by multiplying? It would be the 6. How do I get to a 6? Times 2 and times 2. So let's rewrite this as 10 pi over 6. So 10 pi over 6 is equivalent to 5 pi over 3. Now I'm going to show us right here, I'm going to count, this is a refresher, where do I find 10 pi over 6? Okay, here's 1 pi over 6, 2, 3, 4 pi over 6, 5 pi over 6, 6 over 6, 7 over 6, and 8 over 6, 9 over 6. Here's 10 pi over 6. Right here at this dot is 10 pi over 6. I'm going to come back here at this time, and I'm going to quickly count those. Now, you do need to, as you sketch this, be accurate. Here's 3, 6, 9, 12, 15, 18, 21, 24, 27. Here is where the dot is. And like we did with degrees in our previous lesson, pay close attention in case you did not master this. You're going to draw straight back to the origin, and we always go back to the x-axis. So as you draw back to the x-axis, how you draw the line matters. It needs to be perpendicular to the x-axis. It means it makes this 90-degree angle. The angle that is created with the x-axis, or the angle in the triangle closest to the origin, is always going to be the angle that I'm going to evaluate. So I'm going to go off to the side now, and I'm going to draw this angle, and that helps a lot of students. We're going to draw this angle. And yesterday, so I'm just going to put that angle measurement. Yesterday I realized that what students struggled with is they could do all of this, but they're like, I don't know what that angle measurement is. So let's come back here. If I stop here, this is what I want to know. I want to know, what is this distance? I've just gone 300. How many more degrees, and you can use a calculator, how many more degrees does it take to do 1 revolution? And so if you're not good at that mental math, what we're going to do is we're going to subtract or add up to that x-axis. In this case, we can subtract. 360 is 1 revolution. I've gone around 300. That means this part from here to here. So we have finished right here, just so you know. Here's 10 pi over 6. I make this triangle here. This is 60 degrees. So I'm going to come back here, and this is 60 degrees. So that means that this special triangle that we're working with today, this is a 30, 60, 90. Now, as quick as you can, you have 5 seconds. Please look at the outsides and put in the appropriate measurements. If you are watching this video, that means across from 60 is radical 3, across from 90 is 2, and across from 30 is 1. 1, 2, square roots of 3. If you were present in class today, we talked about SOHCAHTOA, or Oscar had a heap of apples, as a way for you to remember these primary trig functions. These are secondary trig functions, and they're related to each other. These will always have the same sign, these two will always have the same sign, and these two will always have the same sign. Not only that, whatever this number is, if I take the reciprocal, it'll be the cosecant. And the cosine, the reciprocal, is the secant. And the tangent, the reciprocal, is the cotangent. So I prefer Oscar had a heap of apples. That's what's used in pre-calculus and calculus. And the reason for that is if you like SOHCAHTOA, great, use it. But a lot of students say SOHCAHTOA and they don't know how to spell it. If you prefer SOHCAHTOA, please write this down. SOHCAHTOA. And all that is an acronym to help remind you the order. So let's get started right now. If you prefer SOHCAHTOA or Oscar had a heap of apples as a way to remember. Now we're just going to use directions to create this ratio. So sign, if you understand what's happening, please give yourself a little space in front of each. Give yourself a little space in front of each. And before I go through and I actually come up with the ratios, I want to backtrack and I want to revisit All-Star Trig class. All-Star Trig class tells us where in each quadrant things are positive. All things are positive, only the sine, the tangent, and the cosine are positive in these specific quadrants. This terminal angle lands in quadrant 4. In quadrant 4, only the cosines are positive. So right now, please put cosine positive and its reciprocal. Everything else, throw one negative in front. Sometimes students say, like, is it supposed to go at the same level as the division sign? Can it go on top or on the bottom? Doesn't matter as long as there's one negative sign. Okay, sine is a ratio. It's a proportion. It's a ratio. And it's going to be opposite over hypotenuse. So from this angle right here, from this angle, opposite is the square root of 3, and hypotenuse is 2. Now I'm going to flip it. 2 square roots of 3. Flip it, reciprocal. Cosine, SOHCAHTOA. Cosine is adjacent divided by hypotenuse. So from this angle, adjacent helps create the angle, but it can never be the hypotenuse. So adjacent is 1 over 2. Reciprocal, 2 over 1. Tangent is opposite over adjacent. So we're creating that ratio. Opposite over adjacent. So opposite is radical 3. Adjacent is 1, or 1 over the square root of 3. I feel extremely confident in these 6 answers for each of the 6 trig functions, but not all of them are proper. This is proper. I have the right sign, and there's no square root in the denominator. This is proper. This is proper. This is proper. Turn to your partner. You have 10 seconds. What is the shortcut to learning how to rewrite this one and this one in proper form? 10 seconds, go. 10. Talk to your partner, do it. 9, 8, 7, 6, 5, 4, 3, 2, and 1. I'm going to include the sign. I throw the bottom up top, and then I rewrite the bottom with no square root. I rewrite the top, I throw the bottom up top, and I rewrite the bottom with no square root. In my classroom, I feel confident in their ability to do this based on the feedback they just gave me, and so they're going to get started, but I'm going to continue to film example number 2. 7 pi over 6. So here we go. I'm going to find where does this land. There's 1, 2, 3, 4, 5, 6, 7. This is where it lands, right down here. Now, how is that going to help me to accurately sketch this? So I'm going to come back here, and I'm counting by 3s. 3, 6, 9, 12, 15, 18. Here's the 21. It's also 1 over 6, 2 over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 over 6, and 7 pi over 6. So again, my experience working with students yesterday is that they did really well with drawing the triangle. What they struggled with is they knew that we were using 30, 60, 90s and 45, 45, 90s. What they struggle with is what values go here and here. So we need to know what is this value, because that's the value that I am going to evaluate. It's always going to be the part of the triangle that is closest to the origin. That's what I'm going to do. So what I need to know is I'm aware that 7 pi over 6 is the same as 210 degrees. I'm aware of that. And so what we're going to do right now is I want to know how far past 180 did I go? So 210 minus 180 gives me 300. So this angle is 300, and that means this angle has to be 60, because together they all have to add up to 180. So this is the angle right now that I'm going to highlight. You don't have to highlight it, but it allows you to know exactly what we're going to evaluate. We just landed in quadrant number 3. All-Star Trig class, well, quadrant 3 says only the tangent is positive. So tangent and its reciprocal are positive. Everything else receives 1 negative. And now I'm going to create those ratios, or the fractions, that describe 2 of the 3 sides, but the order matters. So sine is going to be opposite of the angle that's selected over the hypotenuse. So here's my angle. Oh, I forgot to put this in. Opposite of 30 is 1. Opposite of 60 is a radical 3, and opposite of 90 is 2. Coming back once again, I'm sorry. Opposite over hypotenuse. Opposite of 30 is 1. Hypotenuse is opposite of 90 is 2. Notice that there's no square root in the denominator. I'm confident in that final answer. Cosine is adjacent over hypotenuse. Well, adjacent means that one of the two sides help create it, but hypotenuse can never be the adjacent side, so that leaves me with the square root of 3 over the hypotenuse 2. Again, I'm not left with a square root in the denominator. I like this answer. Tangent is going to be the ratio or comparing two sides in a specific order of opposite over adjacent. Opposite is 1. Adjacent, as we spoke about, is the square root of 3. Mathematically, this is right, but it's not in proper form. So I'm going to throw the square root of 3 up top, then rewrite the denominator with no square roots. Now, the cool thing is when I do these, I'm just going to take the reciprocal, but keep the sign the same. 2 over 1, good to go. 2 over the square root of 3, mathematically right, but it's not proper. So negative 2 square roots of 3 over 3. And I'm going to take this original one and flip it, and there we go. Example number 3, I've asked students in front of me to locate where they could sketch 2 pi over 3. And I know that this causes many students some confusion. And the reason is because they don't know whether to consider it a 45 degree, 45-45, or a 30-60-90. So we have to ask ourselves, just like example 1, how do I turn the denominator into a 4 or 6? And it's much easier to turn it into a 6 by going times 2 and times 2. So 4 pi over 6. Let's locate 4 pi over 6. Because the denominator is a 6, I'm going back to the pink. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4. This is where it stops. This is the key. This is where it stops. Okay, you ready? Now, I personally, almost in my mind, go back to counting by 3s. So I know I'm going to stop up here. 3, 6, 9, 12. Right there. Now, I always go back to the origin, and then I need to draw a line to the x-axis always, not to the y. That's a common mistake. Now, the way I draw it matters. It needs to be perpendicular. That means when it comes down, it needs to make a perfect right angle. This is tough stuff. So how do I know which angle I'm evaluating? It's always the angle that's a part of the triangle that's closest to the origin. That's the angle. So I'm going to redraw this triangle. And now to figure out this angle, let's keep in mind, what is 2 pi over 3 equivalent to in terms of degrees? Anybody shout out? Mario, do you know? What is this in terms of degrees if you count by 3s? 120. So to get from here to here, kiddos, is 120. How much more remains to come down? Because whatever remains to come down is that angle. So if you weren't sure, it looks like some of you already know. If you weren't sure, we can take and go 180 minus 120, and that's going to be this result, the remainder, which is 60. So this angle is 60. That means this has to be 30. Everything we're working today is based on those common angles, 45, 45, 90, or 30, 60, 90. Okay, are you ready? Across from 60, hopefully this is starting to come into play. Across from 60 is the square root of 3. Across from 30 is 1. I had one student yesterday who continued to get him wrong, and I knew he understood how to create the ratios, but he'd put the numbers in the wrong place. As simple as that. Okay, are you ready? Turn to your partner. Practice quiz. 3 seconds to answer. How do you know which of the primary and secondary trig functions are positive or negative? Talk as quick as you can. Ready, get set, and go. 1, 2, 3. This terminal angle lands in quadrant 2. All-star trig class says only signs are positive. So come up here, put a plus, and put a plus in both the primary and the secondary. Remember, these are kind of related. Everything else gets a negative. If you are in class, I want you to work with your partner, and your goal is to rewrite each of these ratios in proper form in less than 60 seconds. Please begin. You are talking to your partner. This is your chance to pretend you have a friend. Go, start talking. Go, go, go. Okay, sine is opposite over hypotenuse. So here is my angle, right here. There's my angle. Opposite over hypotenuse. Hypotenuse is opposite of the 90. It's in proper form. Okay, let's do cosine. Cosine is adjacent over hypotenuse. Adjacent means it helps create this angle, but it can never be the longest side. So adjacent is 1. 1 over hypotenuse. It's in proper form. Tangent is opposite over adjacent. Opposite is the square root of 3. Adjacent, we've already said, is 1. Once I have the 3 primary trig functions, to figure these out, I'm going to just simply take the reciprocal. 2 over the square root of 3, 2 over 1, 1 over the square root of 3. And then I have to make sure that they're all in proper form. Only one of these exists in proper form. Let's go back up here. How do I do it? I keep the top number, I throw the bottom up top, and then rewrite the bottom with no square root. Keep the top, throw the bottom up top, and rewrite the denominator with no square root. On to our next example. Okay, so initially I was going to have the students in class try this on their own, and if they feel very confident they've been asked to do that, you're able to pressing pause, going through the problem, and then coming back to see if you did it right. But why I actually reversed that direction is that now we have a 4 on the bottom. So 4 on the bottom means we're going to look at 45-degree angles. So I'm going to count. There's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. What is this interior angle, everybody? What is it? It's a 45. These are all 45s. This is 45, 90, 135, 180, 225. So let's come back over here. So 45 will be directly out here. Directly, it's going to cut that 90 degrees. If I made an accurate graph, it's going to cut it in half. We always go back to the x-axis, always go back to the x-axis, and any group that has a 4 on the bottom, anytime we have a 4 on the bottom, we are only talking about 45-degree angles. So here we go. So this is a special triangle. That's a 45, 45, 90. You're welcome to look back in your notes. We need to see what's on the outside. We got a 1, 1, and the square root of 2. Now we just landed in quadrant 3. Quadrant 3, we can see only the tangents are positive. So tangent and its reciprocal are positive. Everything else gets 1 negative. Everything else gets 1 negative. Okay, ready? I know sine is a ratio of opposite over hypotenuse. This is my angle right here. It's this interior angle closest to the origin. Opposite is 1, and the hypotenuse is across from the 90-degree angle. I know cosine is adjacent over hypotenuse. Well, adjacent means it helps create the angle, but it can never be the longest side. So 1 over the hypotenuse. I know tangent is opposite over adjacent. Mathematically, I'm feeling confident right now. Mathematically, I'm feeling confident, but what I haven't done is I don't have it in proper form. So -1 square root of 2 over 2. I threw the bottom up top and then rewrote the bottom with no square root. Throw the bottom up top, rewrite the bottom with no square root. I feel good about those 3 answers. Now over here, I'm just going to flip it. So I have square root of 2 over 1. Flip it, square root of 2 over 1. Flip it, 1 over 1. There's 2 reasons why this may confuse students. First is they don't see a 4 or a 6. So the easiest way to make the denominator into a 4 or 6 is timesing by 2. So -22 pi over 6. So it also has a negative. That means I need to reverse directions. I know that when we have a 6, I'm thinking of this with an interior angle of 30 degrees. So I need to reverse. I'm going to start right here, and this is going to be 1, 2, 3. But by the way, let's do a shortcut. Shortcut. If I go all the way around this reverse, how many of these triangles make one time around? A little bit louder. What is it? 12. Right. For those that are lost on this, there's 1, 2, 3, 4, 5, 6. We'll double it. There's 12. I need to go, as you can see, 22 times and reverse. So I've gone 12. That's once around. So I'm right there at 12. And here we go. 13, 14, 15, 16, 17, 18, 19, 20, 21. Now this is the key. It stops right here. Right here. How much more would I have to go to complete the revolution? A little louder. 60. 60. I'd have to go 60 more. Remember, each one of these, take out the 45s, each one of these is 30. So 30 and 30, I have to go 60 more down. So let's draw this. I ended right here. go straight back to the x-axis, and this interior angle is what I'm always going to evaluate. This is 60 and 30. It's that interior angle. We just landed in quadrant 1. What are all of these going to be? Positives. Okay, we also need to go back and we need to write this down. Opposite of 60 is the square root of 3, opposite of 30 is 1, and opposite of 90 is 2. Ready? I want to challenge you. Can you beat me? You have a 30-second head start. You may work with your partner. Can you fill those out before I finish? You have 30 seconds. Go. Working with your partner, that means picking up that marker in front of you and get going. Opposite. Sine is opposite over hypotenuse. Opposite over hypotenuse. Adjacent over hypotenuse. Adjacent helps create this angle, but can never be along the side. 1 over the hypotenuse. Tangent is opposite over adjacent. All of these are in proper form. Now let's flip them to find the reciprocal. Only one of these is in proper form. This isn't in proper form because it has a square root in the bottom. Positive 2 square roots of 3 over 3. Positive 1 square roots of 3 over 3. For those that are trying to figure this out, am I thinking blue or pink in this situation? Am I thinking blue or am I thinking pink in this situation? For some reason, the board just went out. Give me 1 second to bring it back. Am I thinking blue? Let's make sure this comes up here. Is it blue or pink based on the denominator? A little louder. What is it? It is blue. It is blue. When we have a denominator of 4, our interior angles are going to be 45 degrees in terms of degrees, or 1 pi over 4. So I want to go and do 14 pi over 4. Here's 1, 2. If I go all the way around, there's 8 of them. We talked about that before class started. There's 9, 10, 11, 12. Uh-oh, this is going to be confusing. 13, 14. It ends right here. Does everybody see this? It ends right here, so please find that spot. Okay, this is super confusing. Super confusing. You ready? So I want everybody to write this down. Please write down for me CBS, cosine before sine. Write that down. So we need to come up with the ordered pairs, like we're just going to find ordered pairs back freshman year. How do I find this? Am I going to go left or right? Because that's what the x would say. What is the x value, like the cosine for this? Are we moving left or right to get to this point? Am I going right to get to this point? Yes or no? No. Am I moving left to get to this point? No, I'm not moving left or right. That's why there's a 0. That's why there's a 0. So when you see this, that's why there's a 0 here and there's a 0 here. Now, how far down do I go for the unit circle? It's -1. So we're already going to come up here. You ready? We know each one of these numbers, by the way, can have a 1 on the bottom if you didn't know that. Just like your age can have a number of 1 on the bottom. It doesn't impact your age. Your weight can have a 1 on the bottom. Your height can have a 1. So here we go. Cosine. Cosine right now is 0 over 1. Sine is -1 over 1. When we find the tangent, it is sine divided by cosine. It's another way. So yes, we say opposite over adjacent. Remember, sine is opposite and cosine is adjacent. So if we took the entire meaning of sine divided by cosine, this is what it would come up to be for tangent. So the sine is -1, and I want to divide it by the cosine. What do we know about having 0 on the bottom of a fraction? We know it's not possible. It's determined as undefined. It's not possible. If we plugged it into your calculator, it would say error. Not possible. But now when we find and we flip this, we get -1 over 1. We get 1 over 0. And if we flip this, we get 0 over -1. Remember how these are related. This answer is good. -1 over 1 is the same as -1. Circle it. 0 over 1, by the way, is the same as 0. So I could put a 0 here if I wanted to. Undefined. -1 over 1 is the same as -1. Uh-oh, we've got another problem here. What is this answer going to be? Undefined. Can never be left with 0 on the bottom. And then 0 divided by anything is simply 0. It is. So we have negative 3 pi over 2. A couple different ways you may have already memorized where 3 pi over 2 is. We see the negative, we're going to reverse it. You could turn it into a 4 or a 6, whatever you prefer. I think I'm going to turn it into 6. So times 3 times 3. I want to know where's negative 9 pi over 6. I'm going to count backwards. So 1 pi over 6, 2 pi, 3 pi, 4 pi, 5, 6, 7, 8. Here it is right here. I'm reversing directions. I end at 9 pi over 6. Please put an ordered pair here. It's cosine followed by sine. So I need to fill in what are those values. To get to this point, I'm not moving to the left or to the right. I'm simply moving up 1. The cosine is 0, or we could write it as 0 over 1. The sine is 1 over 1. How do we figure out tangent? Tangent is sine divided by cosine. So 1 divided by 0. And a lot of students, by the way, get confused, like which one of these is undefined? I learned back in probably middle school that if you use your thumb to point to where the 0 is, when the 0 is up top, I'm using my thumb to point up, we're good to go. This is 0. But when the 0 is down below, I'm pointing to where the 0 is, I'm in trouble. It's undefined. I'm flipping them 1 over 1. I'm flipping them 1 over 0. Uh-oh, I'm in trouble. It's undefined. I'm flipping them. I get 0 over 1, which is the same as 0.